Okay, so here's example 7 with the second derivative test. So slightly different instructions from the first 6 examples. What we want to do is find all the local extrema of f of x equals 2x minus 7 at the 5/3. So in the first 6 examples, we just wanted to find out where the extrema occurred, but now we're just asking find all the local extrema. So that means where and what. Okay, so let's jump in with the second derivative test. So, oops, wrong paper. So the first thing we want to do is find the domain of f of x. Okay. So here, what are we doing? We're taking a number x, multiplying it by 2, then subtracting 7. That's all good. Then we raise to the 5/3. So we can raise any number to the 1/3, right? We can raise any number to the 5th. So basically, any value of x is okay. So whether anything is positive, 0, negative, it's all good. We can do this whole operation to any number. So the domain is all real numbers. So let's write that up here. So negative infinity to positive infinity, or all real numbers, or that fancy, goofy-looking r. Okay. So either one of these, all real numbers. All right, so that's our domain. That's good. So that's step 0. Now what's step 1? Find all the critical points of f of x. So let's go ahead and do that. So first we take a derivative. So power rule thing with the chain rule thing, right? So power rule says bring that 5/3 down, and then leave the inside alone in there. And then so now we subtract 1 from the exponent. So 5/3 minus 1 is 5/3 minus 3/3. Okay, 5/3 minus 3/3, which is 2/3. Okay, and then chain rule says multiply by the derivative of the little guy on the inside here. So 2x minus 7, the derivative of that is 2. So now we just multiply all this by 2. Okay, so we can simplify that just a bit. So that's going to be 5/3 times blah 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 times 2. So this is 10/3 times the quantity 2x minus 7 to the 2/3. Okay, so that's our derivative. Now we want to find critical points, so we want to know when is this guy 0 and when is it undefined. Well, is this ever undefined? No, we can take any number, multiply by 2, subtract 7, raise to the 1/3 power, and then raise to the 2nd power, right? We can do that with any number. So again, with this derivative, it's defined for all real numbers, so it's never undefined. So the only places where we're going to have a critical point is when it's 0. So we got to figure out, all right, when is this guy 0? So let's set it equal to 0 and solve for x. Okay, so first we can multiply both sides by 3/10, cancel this. 0 times 3/10 is just 0. And then we can raise both sides to the 3/2, right? So if we raise both sides to the 3/2, that's going to get rid of this. So 2/3 times 3/2 equals the 1. So then 0 to the 3/2 is just 0. So we still have 0 over here. So what we end up with is 2x minus 7 equals 0. Okay. So if we solve for x, we get x equals 7/2. So that's our only critical point. X equals 7/2. Right. And just make sure is that in the domain? Well, the domain is all real numbers, so yeah, we're good. Okay, so that's it for step 1, find all the critical points of f of x. Now step 2, find the second derivative. So let's come back up here, and we're going to find the second derivative. So here's our first derivative, right? F prime of x equals 10/3 times the quantity 2x minus 7 to the 2/3. So the second derivative is going to be, still got the 10/3 there, and then times, so another power rule thing, so bring the 2/3 down, and then we have quantity 2x minus 7, and then our exponent is going to be 2/3 minus 1, okay, so 2/3 minus 1, which is 3/3, okay, so 2/3 minus 3/3 is negative 1/3, right? So 2/3 minus 1, common denominator, 3/3. So 2/3 minus 3/3 is negative 1/3. So our exponent becomes negative 1/3. And then chain rule says multiply by the derivative of what's on the inside here. Okay, so we got the same chain rule thing going on that we had before. So we're going to multiply by 2. Okay, multiply by 2. All right, so we have that. Let's get rid of this also, kind of getting in the way. Okay. So we don't have to simplify this, but you know, let's go ahead and do that. So 10/3 times 2/3 times 2, that's going to be 29ths times 2, which is 40 over 9, times, now this negative exponent, let's rewrite that as a positive exponent, so this is going to be 1 over 2x minus 7 to the 1/3. Okay? Alright, so that's what we have going on here. So here's our second derivative, f double prime of x equals 40 over 9 times 1 over quantity 2x minus 7 to the 1/3. Okay? So that's it for step 2, find f double prime of x. Now step 3, evaluate f double prime to c at each critical point c where f prime to c exists. Well, we only have this one critical point, 7/2, and we know the derivative exists there, because if we plug this into the derivative, we get 0, right? That's how we found this guy. So we're okay to do step 3. So let's go ahead and do that. So f double primed of 7/2, so evaluate the second derivative at the critical point. F double primed of 7/2 equals 40 over 9 times 1 over 2 times 7/2 minus 7 to the 1/3. So if you were working ahead a little bit, or thinking ahead a little bit, yeah, you may have noticed that we have a problem right now. So 2 times 7/2 is going to be 7, minus 7 is 0. So what do we have here? We're dividing by 0, and that's terrible, that's bad, that's incredibly bad. Never ever divide by 0, it's never okay to do that. So what does that mean? Well, first of all, that makes us sad, but second of all, that means we can't go to step 4, right? Because step 4 says if f double prime to c exists, then blah blah blah, do all this stuff here, apply the second derivative test. But f double prime to c does not exist, okay? So this is not a real number, okay? We're dividing by 0, so this doesn't exist. So f double prime of 7/2 does not exist, okay? And sometimes, so this, this is an example of a case where the second derivative doesn't exist, but the first derivative does exist at that point. So things like that do happen. You got to watch out for those. So here, what does this mean? So this means that we just can't apply the second derivative test, right? So, and that wasn't really immediately obvious from the beginning, right? It's, unless you've been practicing quite a bit, it's kind of hard to tell right away just from the start that the second derivative test won't work. So, but the more you get used to it, the more you realize, oh, okay, if I have something like 5/3, well, if I take one derivative, I'm going to get 2/3. If I take another derivative, I'm going to get negative 1/3, and then I won't be able to evaluate at the critical point. But again, if you don't see that right away, that's okay. But anyway, so it's good to go this far, because then we realize, okay, we can't do the second derivative test, but we still need to answer this question, right? Find all the local extrema. So we have to go back to the first derivative test now. Okay. So we did a little bit of extra work, almost for nothing, but that's, it's okay, sometimes that happens. So let's go to the first derivative test now. Step 0, find the domain, we already did that, cool. Step 1, find all the critical points, we already did that, cool. So now step 2 for the first derivative test is make a sign chart for the derivative f primed. So let's go ahead and do that. So we didn't do this in the other videos for the second derivative test because we'd already done them in separate videos for the first derivative test, but this example we haven't looked at before for the first derivative test, so we'll just go through it with this video. Okay, so just we erased the second derivative stuff over here, we don't need it anymore. So now we can set up our little sign chart. So let's go ahead and do that. Remember, always label your sign charts. Okay, so this is going to be our critical point 7/2. Okay, so there's our sign chart. So that was step 3, make a sign chart, and then, or sorry, that was step 2, make a sign chart for f prime of x. Now step 3, determine the sign, SIGN sign, of the derivative in each interval. So we have 2 intervals here. This is negative infinity to 7/2, right? And then this one is 7/2 to positive infinity. Okay. So how do we determine the sign, the SIGN sign of f prime in each interval? Well, we just pick one number from each of these intervals, any number we want. So what's a good one to pick? Well, 7/2, that's 3.5, right? So we can pick 3, 2, 1, 0, -1, etc., etc. We can pick 1.275, which is not a good number to pick, but we can pick it. But let's see, what's a good number to pick here? Let's just go ahead and pick 0. Yeah, why not? So if we pick 0, let's use a different color here. So let's pick a 0. So f primed of 0 equals what? So here's our derivative, f prime of x. So f prime of x equals this, simplifies to this. So we're going to take our numbers that we choose and put them, plug them into here. So from this interval, we're going to pick 0. Okay? So f prime of 0 equals 10/3 times 2 times 0 is 0, minus 7 is -7, and then to the 2/3. Okay. Now, this might look kind of bad, but, you know, to the 2/3, what does that really mean? So another way of writing that is 10/3 times -7 squared, and then to the 1/3 power. Okay, so that's another way of writing that. So this is 10/3 times -7 quantity squared is 49 to the 1/3. Okay. 49 to the 1/3, what's that? It's not really a nice number, but we don't care what its value is. All we care is that it's positive, right? If you take a positive number to the 1/3 power, let's zoom in a little bit. Positive number to the 1/3 power, that's going to be another positive number. So 10/3, positive number, times positive number to a positive power, or to this fractional power here, 49 to the 1/3. So everything's just positive, right? Positive times positive number, so that's all greater than 0. So that means in this entire interval up here, f prime is positive. Okay. Now what about this interval over here? Let's pick 10. Okay, so remember 7 halves is about 3.5, or exactly 3.5. So we'll just pick 10 from this interval. So f prime of 10 equals 10/3 times the quantity 2 times 10 minus 7. Okay, so 2 times 10 is 20, minus 7 is 13. So this is 13 to the 2/3. Okay, so we don't really have to simplify this anymore. We can do the same kind of thing we did up here, where we can say 13 squared and then to the 1/3, and then 13 squared is 169, and then to the 1/3 power is some ugly number we don't care about. But we don't really even have to go that far. Okay, so 10/3 times 13 to the 2/3. 10/3 is a positive number. If we take 13, raise it to the 2/3 power, that's still a positive number, right? So positive number times a positive number. So this whole thing is positive, greater than 0. So that means since f prime of 10 is positive, then that means f prime must be positive in this entire interval. Okay? And we've done quite a few examples like that a few videos ago. So anyway, what does this mean? Well, we do have a critical point here, but f prime is positive on both sides. So, well anyway, that was it for step 3, determine the sign of f prime of x in each interval. Now we apply the first derivative test to find the extrema. So when we apply the first derivative test, we see, okay, first derivative is positive in this interval, first derivative is positive in this interval. So this actually means that f is increasing on the interval -infinity to 7 halves. But it's also increasing on this interval from 7 halves to positive infinity. Okay. So actually the first derivative test tells us that there is not a local min or a local max here. So even though we do have a critical point, there's no local extrema there. So since this is our only critical point, as it turns out, this function has no local extrema. So f of x has no local extrema. So all that work for a very anticlimactic result, but I did want to just point out that, you know, sometimes you will have a case where if you try the second derivative test, you know, the first derivative might actually exist at that critical point, but the second derivative might not. So that will come up. I don't think we've done an example like that, but it will come up, and here's an example of it. And so we had to go back to the first derivative test to answer our original question, and the first derivative test told us that f of x has no local extrema. Okay? And that's example 7 with the second derivative test.